We're back, continuing chapter 1 videos. So this is picking up with derived units. So in the previous video we talked about sort of all the base units, many of the base units for the SI system. And so what we get when you start combining base units, you get what we refer to as derived units. So a common derived unit that you'll deal with quite a bit is volume. Okay, so essentially a volume is nothing but length times width times height, right? And so all of those are basically some version of a length. And so we have meters times meters times meters. So a volume can be expressed in any version of a cubic SI unit. Okay, so cubic meters, cubic centimeters, anything like that, any kind of cubic length measurement. Now the SI unit for volume is the cubic centimeter. Now, interesting fact, so 1 liter is defined as 1,000 cubic centimeters. Okay, but also 1 milliliter which is 10 to the minus 3 liters equals 1 cubic centimeter. Okay, because we have this relationship of milliliters to liters. So there are 1,000 milliliters in 1 liter. So if there are 1,000 cubic centimeters in a liter and 1,000 milliliters in a liter, then 1 milliliter equals 1 cubic centimeter. So if you've ever watched any kind of like hospital shows on TV or in the movies, and you often hear doctors or nurses say, I need 10 cc's of something, they're talking about milliliters because cc stands for cubic centimeter. Right, so they're asking for a volume in terms of cubic centimeters. Other derived units that we have are things like for pressure is a Pascal. Okay, and a Pascal is defined as 1 kilogram per meter second squared. Okay, unit of energy is a joule. And a joule is 1 kilogram times meters squared over seconds squared. Okay, so they're all combinations of the standard SI units. So we can do conversions with these types of units, no problem. Okay, the more complicated ones are when we have to convert using square or cubed units. Okay. The good news is they work exactly like doing the conversions that we did in the last video. Okay, we set up a ratio. The only trick is that we have to add one more step. Right? So the trick is to use the conversion you know and square or cube it. Right, so let's do a little example here. So here's our question. How many square meters are in 105 square kilometers? Okay, so we're talking about a unit of area, right? And this is a common one if you're dealing with like plots of land or areas of land, that sort of thing. Okay? So the conversion that you know between meters and kilometers you have 1 kilometer is 10 to the 3 meters. Okay, so that's our conversion that we know, but we're dealing with square kilometers and square meters. So all I have to do is take that conversion and square it. So 1 km over 10 to the 3 meters, and I square the whole thing. So what that becomes, let's make that a proper arrow. Yeah, that's disturbing. Okay, so what it becomes is 1 square kilometer over 10 to the 6 square meters. Okay, so if you square the entire quantity, you have to square both the things. Okay, so when I apply that now squared situation to my conversion, the tactic exactly the same. So 105 square kilometers is my given information, and I want to put square kilometers on the bottom. So 10 to the 6 square meters over 1 square kilometer. Right, so my square kilometers will cancel out, and my answer comes out to be 1.05 times 10 to the 8 square meters. Okay, so dealing with conversions of square and cubed are exactly the same. The only trick is that you have to remember to do this. All right, but otherwise the problems work just like they do with any other unit conversion. Let's do another one. How many cubic centimeters are there in 4 cubic kilometers? Okay, so that would be something like taking a volume of ocean water and converting it to milliliters. Why you would want to do that, I don't know, but you certainly can. So our conversions, we're going to have one that looks like 1 centimeter is 10 to the minus 2 meters. And since we're dealing with cubic units, we're going to cube that. And our other conversion is to go from meters to kilometers. So 1 kilometer is 10 to the 3 meters. And we're going to cube that. Right? So what those conversions become is 1 cubic centimeter is 10 to the minus 6 cubic meters. And 1 cubic kilometer is 10 to the 9 cubic meters. So now that I've cubed my conversions, I can approach the problem exactly the same way. So start with my given information. And I'm going to use a conversion that gets rid of the kilometers, so I'm going to put that on the bottom. So 10 to the 9 cubic meters over 1 cubic kilometer. And my next conversion is going to get rid of the meters, so I'm going to put that on the bottom on the next conversion. And when we calculate that out, we're going to get 4 times 10 to the 15 cubic centimeters. All right, so when I enter that in the calculator, just a quick refresher, anything on the top of a conversion, I multiply. Anything on the bottom of a conversion, I divide. So when I enter this in my calculator, I'm going to say 4 times 10 to the 9 divided by 10 to the minus 6. Right, so I hope you're starting to see that we can apply this unit conversion strategy to many different situations as long as I make everything match up. My cubic kilometers will cancel. So if I stopped at that first step, I would have an answer in cubic meters. And then in my next step, my cubic meters cancel, giving me an answer in cubic centimeters. Now our next topic, we're going to get away from this metric conversion and we're going to deal with temperature. And specifically being able to convert between different units of temperature. Now, I want to make something clear right now, because we're going to deal with it later in the semester when we get to thermochemistry. Temperature is not the same thing as heat, okay? Temperature is strictly defined as a measure of the amount of thermal energy. Okay, when we get into the thermochemistry section, it'll be clear that that's a different concept than heat as in and of itself. Okay, so whether you use a thermometer to measure the amount of thermal energy in an object, or in a ball of gas or bottle of water, whatever. So there are 3 common temperature scales. So in most of Europe and the rest of the world, they use Celsius. In the United States, we use Fahrenheit, Fahrenheit. And in the science community, they also use, Kelvin. Right? And so just to give you an idea of the differences, water boils at 100 degrees Celsius, at 212 degrees Fahrenheit, or 373 Kelvin. And water freezes, as you might guess with Celsius, it freezes at 0. Fahrenheit, we're the weirdos in this country, 32 degrees Fahrenheit. And then in kelvins, it freezes at 273 Kelvin. So Celsius and Kelvin track exactly the same way, right? So if we look at the difference here, we've got a difference of 100 with Celsius, and if we look at a difference here, we have 100 difference in Kelvin. Now with Fahrenheit, it's something entirely different. So it's something like 100 and almost 200. I'm not going to do that mental math off the top of my head. So 1 degree change in Celsius equals 1 Kelvin change. All right? All it is shifted by 273. So our conversion between Celsius and Kelvin is a simple one. So temperature in Kelvin equals our temperature in Celsius plus 273. Now some books and some programs will say 273.15. That's all well and good. As far as the work that we'll do in this class, 273 should be sufficient enough. Certainly if you show 273 on your work for exams and stuff, I'm going to take it. Okay. So most chemistry measurements are either going to be in Celsius or Kelvin. All right. These are the most common types of temperature measurements in science. You'll almost never find any kind of scientific paper dealing with Fahrenheit unless you're dealing with something medical or biological sometimes. But most of the time, scientists stick to Celsius and Kelvin. Unfortunately, our conversion from Fahrenheit to Celsius and vice versa is not quite so simple. Okay, so from I always messed up the spelling of this word, Fahrenheit to Celsius. All right, our equation looks like this. So temperature in Fahrenheit, I'm not going to spell it out every time, is 9/5 the temperature in Celsius plus 32. All right. Now to go the other direction, temperature in Celsius equals 5/9. And here, you need a parenthesis or a bracket. You need to separate this part. Temperature in Fahrenheit minus 32. Right? This piece has to be done first, okay, before you multiply by 5/9. All right, so let's do a little practice. Let's convert 76 degrees Fahrenheit to Celsius. All right, so our temperature in degrees Celsius is 5/9. 76 minus 32. All right, and this is our temperature in Fahrenheit. And we'll get an answer of 24 degrees Celsius. Let's go the other direction. So, well, not the other direction. Let's convert to Kelvin. So since we're already in Celsius, my temperature in Kelvin is just 24, which is our temperature in Celsius, plus 273. 297 K. All right, and that's pretty close to a very, very common number that you'll see, especially when we get into gases and other things like that. We deal with Kelvin temperatures a lot. Room temperature of 25 degrees is 298 Kelvin. Right? Really common. Let's convert 368 Kelvin to degrees Fahrenheit. And so the easiest thing is to first convert to Celsius. First convert to degrees C. So temperature in C is 368 minus 273 gives us a temperature in Celsius of 95 degrees. And then converting to Fahrenheit. So our temperature in Fahrenheit is 9/5. 95 plus 32. So we end up with a temperature in Fahrenheit of 203 degrees Fahrenheit. All right, so your temperature conversion's really the only tricky part. Let's come back up to our equations. Really the only tricky part is remembering this part right here. When we're converting to Celsius, you have to remember those parentheses because otherwise the math won't work out right, okay? But that's going to be it for this particular video. When we come back in the next video, we're going to be talking about density.